Welcome to the second video about if statements. Here we're going to be looking at using other conditions. There's quite a lot of detail in this video, and I'm going to start introducing the idea of character encoding, or ASCII, essentially how we store text, mainly because it becomes relevant when we start to compare text together, and I think that background knowledge will help you understand this a bit better. So just recapping the last video, we looked at what an if statement is. The idea is that an if statement will have a condition that it will test. In this example, we've got color is equal to red. That test will either be true or false, or a boolean. If it's true, the code that has been indented inside it will be run. So that is just a little recap of what we've already looked at. Also, remember that if statements are a way of representing decision boxes in flowcharts. So the decision box on the screen, the flowchart, is exactly the same as the code shown in Python. So in this video, we're going to be focusing in on some of the other conditions. We are primarily going to be focusing in on the less than, greater than, and their kind of partners in crime, the less than or equal to and the greater than or equal to. We're going to be looking at this through numbers as well as using text as well, because although their usage pretty much the same, how they work is slightly different, so it's actually quite important to know the difference. We're now going to start to explore how to use greater than, less than, and the other operators in Python. So here I've got a basic program, so let's recap some stuff we've already covered. So first of all, we've already looked at the input command. Input command allows you to interact with the person using your program, and it will ask them a question or give them a prompt. They can enter a response to that prompt, and it will come back as text or a string. Because in this program I want to deal with numbers, I need to turn it into a number using this command int. And what will happen is it always runs what's inside the brackets first. It then, which will return text. It will then turn that text into a number using the int command, or cast it is the correct term. It will then assign that value into the variable y. So by the time we get to line 2, the variable y will contain a number that the user has entered. Then on line 2, we are going to do a condition, which is y is less than 10. So if the y is less than 10, the number they've entered is less than 10, then that becomes true. It will run the indented code here. So let's see in action. So I'm going to run the program. I'm going to enter a number, let's say 5. And you can see it says 5 is smaller than 10. If I run that program again and I enter a number maybe 12, you can see nothing's printed out. The reason nothing's printed out is because I have nothing after this program. So if y is not less than 10, so it's over 10, for example, it will do nothing else. Let's see what happens when I enter number 10. It still doesn't print out anything because 10 is not smaller than 10. Okay, it's the same, it's equal. Let's tweak the code slightly. And if I did that, I can then say is smaller or equal to. And then I run that again. I enter number 10. You can see that it then says 10 is smaller or equal to 10. So I'm just going to undo those changes. And let's try adding another if statement. This time I want to say, well, if it's not less than 10, I'm going to check to see if it's bigger than 10. So I'm going to go if y is greater than 10, print y, comma, is greater than 10. I'm going to run this program now. So I'm going to enter the number 4. It says 4 is smaller than 10. I'll run it again, enter the number 12. It says 12 is greater than 10. If I run this code and enter the value 10, and again nothing will print out because 10 is not smaller than 10, it's not bigger than 10, so both these if statements are effectively ignored. Let's do one last one. And using the equality check that we used in the last video. Oops. And then we can say y is equal to 10. If I run this program one last time and I enter number 10, you can see it now does that. So this is how we can start to use the other conditions. We can use less than, greater than, or equal to. You'll be very familiar with using greater than with numbers already because you probably already come across it in maths. However, one common mistake I see with students is that they aren't aware you can use these operators with text as well. So let's explore how this works. Here I've got a program where it's asking for two names. Okay, so I've got name 1 and name 2. It'll then compare the names together. So if they're the same as one another, it's going to print out the first thing. So let's test that one. Let's enter a name, Bob. Enter another name, Bob. You can see we've got the same name. The next one says if name 1 is greater. Well, what does that mean? Let's have explore. So if I type in the name Percy and then the name Alan, it says name 1 is greater. Now you probably noticed that it has more letters, and you might be forgiven for thinking, well, that must be the reason why it's bigger. Let's test this one again, and I'm going to type in Adam again. Actually, let's type in Zach and Adam. It says name 1 is greater. So they have the same number of letters, so it's not comparing it to the number of letters in the word. What it's doing is it's looking at the first letter and it's using the alphabet. So it's comparing the Z to the A. Now because Z comes after A in the alphabet, it considers this one to be bigger. Let's try this one again, and this time I'm going to type in Adam and Alan. It says name 1 is smaller. So how does it work this one out? As you can see, the first letter is the same, it's both A. So it takes the second letter now. Because D becomes before L in the alphabet, it considers Adam to be smaller than Alan. So alphabetically speaking, Adam would come before Alan. So when you maybe sort a list in File Explorer, this is how it will sort it. It will actually do it based on the letters. Always compares the first one, then the second one, then the third one, and so on and so forth. If they're all the same, then considers them the same. Let's consider one last scenario. Or two last scenarios actually. So I'm going to type in Bob again. And I'm going to type in twice. Now notice it now says name 1 is smaller. What's the difference? Well, if you notice, I've got a capital B here and a lowercase here. So it's looked at these ones and decided that the one with the capital is smaller. So it is case sensitive, okay? It doesn't think that two names or two words with different capitals are the same, even though they are the same word. So let's run this one last time, and I'm going to type in Zach with a capital Z and Adam with a lowercase. Now it says name 1 is smaller. Now this seems a very odd result, doesn't it? You can see Z comes after A in the alphabet. So you'd expect Zach to come after Adam. So you'd expect Zach to be bigger. However, when we are comparing a capital letter to a lowercase letter, it always considers lowercase letters to be bigger. The reason for this, and I'm going to show this later in the video, is to do with the ASCII table. I'll explain ASCII for those of you who may not be familiar with it later on this video. But long and short of it, lowercase letters are considered to be after uppercase letters in the alphabet. Let's now consider how text is stored inside a computer, because it becomes relevant when we're trying to use if statements. So inside a computer, everything is stored as binary, or ones and zeros. Binary is a base 2 numbering system, and it allows us to store any data you can think of in ones and zeros. So images, sounds, movies, anything you can think of is all stored using binary. Text is no different, so text can be stored in binary as well. And the process of turning text, so letters or words and things like that, into binary is known as character encoding. The word character represents a single letter or symbol or digit, and coding is the method of actually turning that letter into binary. So how can we do it? Well, a trivial way of doing it is by giving a number to each letter. So turning numbers into binary is really straightforward using the binary numbering system. There are loads of videos on the internet. If you don't know how that works, I do have a look at it. But once we have got that kind of method of turning a number into binary, then all we have to do is give a number to each letter. Okay, and the easiest way you can do it is by thinking, okay, well, C is the third letter in the alphabet, therefore I'm going to give it the number 3. So that is kind of the first step, is to give a number to each letter. S is the 19th letter in the alphabet, so we're giving it the value of 19. We can then turn that into binary, like so. Just very briefly to say why these numbers are equivalent. In the binary system, we have 1, 2, 4, 8 and 16. That's a terrible 8 and 16. So here I've got a 1 underneath the 1 and the 2. So 1 plus 2 is 3, which is why it's a 3. Here I've got the same thing. So I've got a 1, I've got a 2, 4, 8 and 16. And if I add up those three numbers, 16 plus 2 plus 1 is obviously 19. So we can represent our characters in binary. But what about symbols? So the method is actually the same. I need to find a number to represent them. So what number should we use though? And that becomes the big question, is that, well, I might choose, I know, the number 30 for my star, and 31 for my exclamation mark, but you might choose a different number, or another company might choose different numbers. And actually in the first days of the computing, this was a big issue because some manufacturers were using one encoding scheme, others were using others. So essentially it was very hard to take a file created on one computer and bring it to another one, because they are using different encoding schemes and they reread differently. So in order to help matters, an encoding scheme was created. ASCII is the most common standard that is in use for storing characters in a computer. Most encoding schemes are based on ASCII, therefore anything that is stored as text tends to use the same ASCII values for the first normal letters, so A's, B's, things like that. It is a standard. So everyone has agreed this is how letters and numbers should be represented, and therefore everyone can read those files. ASCII stands for American Standard Code for Information Interchange. No one ever calls it that, everyone uses the word ASCII. So here's the ASCII table. I use this table, it might seem complicated at first, it's actually dead easy, so I'll help you to read it. So let's consider one of the letters. Let's consider the lowercase a. Well, what number has been assigned to that? Well, all I have to do is look up in which column it's in. So it's in the column 7 and it's in the row 90. So the value for a is 97. Okay, so that is its ASCII value. Let's look at a number. So let's look at uppercase A. Well, again, that's in column 5 and it's in row 60, so that is going to be 65. And you can do that for any of these. So let's take the plus symbol. It's in column 3, row 40, so it's 43. Okay, and hopefully you get the idea. Now notice that the lowercase letters are after the uppercase letters, so technically the uppercase Z, which is represented by the ASCII value 90, is smaller than the lowercase value for A, which is 97. Okay, and this is why you get that weird situation where uppercase words come before lowercase. So that's the reason behind that. Now it's your turn to do some programming. What I'm going to ask you to do is to write a program which will award a prize to someone based on how many points they have. So those points could be anything. It could be a number of green stars, tickets. It doesn't matter. It's just a number. Okay. I've broken it down a bit for you. So it's going to ask for the number of points. Now you probably noticed that I've not given you the exact code to start you off now, but I have given you code patterns. Now what do I mean by that? Well, these are bits of code that you've already done and already used so far, and you just need to take it and tweak it. Okay, so one of the most important skills as a programmer is to identify when you need to use a certain bit of code, how you need to change that to match your problem, and then obviously put it all together to solve it. Okay, so this is an important skill to develop, which is why I'm getting you to do it this way. So if we're asking for a number, that's an interaction, isn't it? We're going to be asking, getting input from the user. Therefore, we're going to be using this code pattern. Now, again, you don't use that code exactly. You need to tweak it slightly. Maybe change the prompt to be maybe how many points you need, and change the name of the variable to something a bit more suitable. Then you are going to need to write an if statement. So if the number of points is greater or equal to 20. Now here I've given you what an if statement should look like with a number. This one says less than 5. You need to tweak it. One key point to bear in mind is that the name of the variable should match here. Now, although I've got A here on both of these, you should have something which is a bit more descriptive, maybe points, I don't know. Then you are going to be displaying a value. Now, to display a value to output, you're going to use the print command. So what I have done is essentially given you all the kind of code patterns you will need for this problem. Your job is to decide which one goes with which, and I've kind of already given you that clue because if statements will go from there. Yeah, so when you do an if statement, you can use that. When it's output, when it says display, you're going to be using that code pattern, and when it's input, you're going to be using that code pattern. I'm sure that's obvious, but I'm just getting you used to spotting that, because eventually the training wheels come off and you're on your own, and you have to be able to do that like that. Okay. Let's consider the model answer to this question. I'm just going to make a point clear. When I say model answer, I'm going to be only using the things that I've introduced so far. I'm fully aware that this could be done much simpler than the way I'm about to do it. Okay, so this is just using the if statements that we have looked at so far. So the first thing the program has asked to do is to enter the number of points. Now I've used the input command, as you can see, and I put a prompt in there, so enter the number of points, and then I've also cast that into a number because I want to compare it as a number. So I've used the int command as well as the input commands. Notice at the end of the line I've got 2 brackets. A common mistake people make is to forget the 2 brackets. They only put 1 when they use int. One way to remember it is I always have to be balanced, so if I've opened 2 brackets, I must close 2 brackets as well. The next thing I need to do is put my if statement in. So if points is greater or equal to 20. Now I've put equal in because if it is equal to 20, you still get the prize. So I'm just going to print out, you get a prize. I'm then going to do another if statement. If points is less than 20, print, you do not get prize. A couple of things about this one. So if I run this one and enter the points 89, I get a prize. If I enter the points, sorry, do that again. If I enter the point 6, maybe, I don't get a prize. If I enter the point 20, you can see I get a prize. If you forgot, or if you just put an equal sign here as well as less than and run it, what you're going to get if I enter the number of points 20, it says I get a prize and I don't get a prize. A bit of a Schrodinger's cat situation. The reason for that is because 20 is going to be equal to 20 here and here. So these conditions are both going to be true. Therefore, both of them are going to be printed out. If I didn't put an equal sign in at all, and I run it, and I type in 20, I'll get nothing. So long and short of it, you must always make sure that when you are kind of doing a range of numbers and you have a specific range, that if it's greater than or equal to, you don't use the equal any other one. So you can think of these as opposites of one another. Just because there's going to be some smarty pants out there who knows this can be done through using else as well. That is true. In the next video, I'm going to introduce else and elif, so you can actually start to use those to play around with. However, that would be the answer that I was expecting for this video. So here's a challenge task for you. Now I'm giving you the starting point for this one, which is just the variable 63. Okay, so secret equals 63. You're going to come up with your own secret number. Doesn't matter what it is. It really does not matter. But you're going to write a simple secret number guessing game. A single turn, so one go, secret number guessing game. So they only get one guess, essentially. The user can enter their guess. If that guess is the same as secret, then it's going to say well done. If the guess is smaller, then you're going to say that was smaller or too small. If it's bigger, then you're going to say it's too big. Have a go at this one. At the end of this video, I have got a model answer for this one, just in case you're not sure, but I'm sure you'll get this really easily. So here's the model answer. You may want to pause the video so you can check your answer to this one. I'm not going to give you this code directly other than in the video, because this is to compare your answer, not to copy and paste it and run it, because that's not really what I want you to see. So here's the model answer. I am sure there's other clever clogs out there that will come up with better solutions to this one. I'm just using the code we have looked at so far, so this is why there's no elifs in there or else's or anything like that. It is just simply using the code we have covered so far. Okay, so do have a look through this one, and hopefully your solution was similar or even the same as my one.